In the second part of section 3.1, you're going to be classifying a linear system and determining the number of solutions, and also determining whether or not a point is a solution. So let's talk about, is a point a solution to a linear system? Well, the point is a solution to a linear system if it satisfies both equations. Okay, so let's look down here. We want to check to see if this point 2, 4 is a solution to this system. So what we're going to do, this is our x, this is our y. We're going to substitute the values in for x and y in both equations, and it has to be true for both of them. So let's check the first equation. We're going to substitute 2 in for x and 4 in for y. So it's going to be minus 2 times 4. The question is, does that equal negative 6? Well, 2 minus 8 equals negative 6. So yes, it's true for the first equation. We also have to check the second equation. So now we're going to use this one, and we're going to say 2. Remember, our value for x is 2, so 2 times 2. And then we're going to add 4 to it. The question is, does that equal 8? So 4 plus 4 equals 8. That is true. So yes. So that means this point, 2, 4, is a solution to the system. In other words, when these two lines are going to intersect at the point 2, 4. Okay, now, when you graph two lines, one of three things can happen, and I have a little table down here for you. You can have one point of intersection, which means you have a solution. If that happens, we call this system consistent and independent. So think of independent. People who are independent, they like to work by themselves or in a group of one. So one solution, independent. That happens when your lines have different slopes. So if you just think about it, lines that have different slopes are eventually going to intersect. They could look like this. You know, they could both be positive. They could both be negative. One could be positive slope, one could be negative slope. But once they intersect, we know that their lines have different slopes. Okay, the other thing that can happen is it can be consistent and dependent. So that happens when the lines are coinciding. So they're exactly the same line. They have the same slope and the same y-intercept. And sometimes you can't always tell that the lines are the same until you put them in both in slope-intercept form. So consistent and are systems that have one or more solutions. So one or infinite solutions. The other thing that could happen, the lines may not intersect at all, which means they're parallel. This is inconsistency, or inconsistent. There's no consistency, which means they don't have anything in common. The lines are parallel. They have the same slope, but a different y-intercept. Okay, so in order to classify them, I mean, it's easy to see when you have the graphs, but I want you to be able to do that without the graphs. So, to classify a system of equations, you want to put all the lines in slope-intercept form. You're going to look at the slope and the y-intercept, because that's what it talks about here. It talks about the slope and the y-intercepts. Now, there are two cases where the system can be classified as consistent, which means there's something consistent between the two. For this reason, when a system is consistent, the words independent or dependent need to be used. So just think of independent means they're intersecting in one place. Dependent, it's the exact same line, and they depend on each other. Okay, let's go to the next page now, and we're going to just kind of restate what we have just said. If the two lines have different slopes, the lines will eventually intersect, and the system is consistent, independent. So there's some consistency, something that they have in common. Case number 2, the lines have the same slope and the same y-intercept. So that means they're exactly the same line. And they are consistent. There's a consistency between them. And they're dependent. Again, they depend on each other. And they have an infinite number of solutions because if we look, they're intersecting every single point on that line. The third one is the same slope but different y-intercepts. The system is inconsistent. It has no solutions. Remember, solutions are only where the lines intersect. Now, that doesn't look very parallel, but just pretend that's parallel. So here are your three solutions, both in words and with diagrams. Okay, so now what we're going to do is we're going to classify this system. The first thing that you want to do is put it in slope-intercept form. Okay, so let's do that with this line. We're going to say 7x minus y equals negative 11. I need it in slope-intercept form, which means I need to solve for y, so I'm going to subtract 7x from both sides. That's going to give me negative y equals negative 7x minus 11. Now, we don't want negative y, we want positive y, so I'm dividing by negative 1, which leaves me with y equals 7x plus 11. That's my first line. Now we're going to do the second line. The second line is just needs one step to, we're going to divide by 3, all three terms, and we get y equals 7x plus 11. Now these two lines didn't look the same to start with, but look what happens when we put them both in slope-intercept form. We have the same slope, same y-intercept. So let's go back up to our three cases here. If we have the same slope, the same y-intercept, then we know that the lines or the system is consistent and dependent. Okay, so circle one. Consistent because there is some kind of a consistency. Then we have to decide if it's just one point where they intersect or all of the points where they intersect. So if it's independent, there's only one place they intersect. If it's dependent, there's an infinite number of places where they intersect. So this one is dependent, and there's an infinite number of solutions. Okay, you have some to try on your own.